Okay, so this is our first tutorial in life cycle costing calculations. So we're going to go through incrementally, starting with the basics in terms of present value, to series calculations in life cycle costing, and then to more kind of modeling in terms of life cycle costing and construction costs. But we got to learn the basics first, and we got to learn the functions first before we move forward. So working with this today here, we've got a PV calculation, a present value calculation, and this assumes essentially that we need a sum of money in 10 years time, and that sum of money is €500. So let's kind of imagine that we need to replace floor finishes in a living room, and it's going to cost us €500. Now, of course, we won't know exactly what it's going to cost depending on escalation and inflation over a course of a year, but in this particular calculation, let's assume that we do know we need €500. So this is what's called a single present value, because it's a single sum of money rather than a sum of money that's paid out every year, and we need to calculate the present value cost of that particular sum of money in today's money based on an interest rate of 3%. So we can do it a number of different ways. In Excel, we can use the calculation that we looked at in class, which is 1 over the power of 1 plus or we can use Excel functionality in respect to equals to the power or equals to the PV. So I'm going to show you how to do that. Here is our calculation. We need 500 future value. It's over the course of 10 years, and it's a discount rate of 3%. Now I want to use Excel so that if any one of those items changed, my calculation will change. Down here we actually have the explanation of the PV function, so the function in Excel that does this calculation, but of course we can do it manually as such in Excel as well, and what those different, I suppose, terminology means with respect to making the payment, because you can use this function for a series of payments, or you can use this function, PV function, for a one-off payment. Okay, so starting with what we did in class in the lecture, which is essentially just this calculation here, we're going to calculate the PV, the present value of that €500 using just this simple calculation here. So let's start with that. So I'm going to click on the first, delete what's there. That's just going to show you the complete calculation. So when we're starting, I suppose, a formula, we always start with equals. So equals, and it's 1, because I'm looking at what's going on here, 1 divided by, open brackets, 1 plus, and then I'm going to click the percent. So I is my discount rate, it could be shown as D there, but I is essentially the interest rate. Okay, so 1 plus B4, I could type B4 in as well. I'm going to close my brackets, and then it's to the power of, and that is Shift 6, so this little arrow up above the number 6 on your keyboard, to the power of what, and maybe I'll use the series of payments down here, click on 10. So it's to the power of 10. Now that is my calculation to calculate my factor, which is my single present value. So I'm going to put brackets around the last item there, which is the L15, and the first item, to signify that that's one complete calculation. And then that factor, the resultant factor, in fact, if I hit return here, I can see that it's 0.74. I'm going to go back up into my calculation and multiply by that 74 by the 500. Okay, so you can actually see based on where the cells are located, or the color boxes around the cells, what's happening there. So that is essentially that formula in Excel. It's horizontal instead of kind of this vertical representation that you get when you look at it, I suppose, in a textbook. Always start with equals, and then once you've calculated it, hit return. So we got €372.05. What does that signify? Well, if I put 372.05 in the bank today at 3%, in 10 years time I'll have €500. Okay, what do I need to put in the bank today to pay for that floor finish at €500 is essentially 372.05, and that is the time value of money. Over the course of 10 years, that money would grow, or if you reverse it, it would discount, and that's why that's called a discount rate, because it's essentially represents what that money represents in 10 years time, discounted back to what's called year zero. Okay, so that's the simple single present value calculation. So moving on from that, I'm going to use this power calculation in Excel. So we're just going to delete it there, and that is equals, type in to the power. Now when you do that, you get this, I suppose, explanation of what the formula does. It returns the result of a number raised to the power, and that's essentially what we're doing here, because that's what that is. And it is power, open brackets. The number we are looking for is the 1 plus discount rate. Okay, and that is to the power, comma, I'm following what's going on here. So this is this first item here, to the power of, that's what the arrow up n is. So to the power of the 10. So I'm going to click in the 10. Now in this calculation, if you don't put in minus in front of L15, it won't return the correct figure. So I'm just going to put minus in L15 there. So it's minus 10 rather than 10. I'm going to enclose that with a brackets. Okay. And then I'm going to multiply it by the 500. Now let's hope this works. So there we got that calculation, equals, open brackets, 1 plus b4 to the power of L15, which is 10, close brackets, multiplied by the 500, and there we have the exact same calculation. If I want to double click, there's the 3% over the course of 10 years with the future value of 500, and that gives us the 372. Now again, if I changed, let's say, that 4% to a 10% interest rate or discount rate, you can see the effect it has on my two sums, my two calculations. So because I've got an exponentially more or a higher interest rate, I don't have to put as much money in the bank, because that's accumulating at a 10% compound rate over the course of 10 years. So if I have a high interest rate, I don't have to put as much money in the bank. So the present value of that money in year 0 is less than what it would be at 3%. So I'll go back to 3%. So our last calculation is the actual present value calculation, which is designed for exactly what we need to do in Excel. So I'm going to use it, equals. This is it up here in terms of an explanation, but as you type it in, it will explain what it is. Equals PV. Okay. And then this returns, you can see it there, returns the present value of an investment, the total amount that a series of future payments is worth now. Now, there's two things happening here. You can use this PV as a series of payments, or you can use it as a one-off payment, which is essentially what we're using here. So it does two things, and you'll see what I mean in a second. So I'm going to open the brackets. The rate I'm using is 3%. The next one is comma. So you can see it down here, the number of payments, and that is 10. Okay, then I've got comma PMT, which is what I'm on next. Now the PMT is the payments made in each period. Because I'm not using the calculation for a series of payments, I'm not going to use that. So I'm going to click 0 there. And then the next one, which is why I've got it in red here, is the FV, and that is the future value, or whatever the cash balance is that I'm looking for, and that is the 500. So I'm going to click that. Now when I'm doing this one, I also have to put a minus in front, I believe, a minus in front of the L15, otherwise it'll return an incorrect value. So click minus there, and then comma, and again I'm down here, type. Now the type is either a 0 or 1. Type indicates when payments are made. 1 is payments made at the beginning of the year, and 0 is payments are made at the end of the year. I want the end of the year here, so I'm going to click 0. So we want it to be essentially at the end of the year rather than the start. It'll give us a different, I suppose, future value or different present value. And then I'm going to close my brackets. So that's my series of payments there. And you can see that it's 3%, L15 in terms of number of payments, or the period of payment, and then the L17 being the future value. So hopefully if I click return, I get 372, and I do. So that's our first little tutorial. Next we'll move on to a tutorial that encompasses escalation. Okay, moving on from our first sheet that we did single present value calculations to our next sheet, which is also single present value calculations, but this time we're dealing with escalation. So this gives us an opportunity to cost it in today's money bring it up to an escalation over a period of time at a certain rate at 2% to 10 years, and then we discount it back. So the main thing is the difference between these two, the 5% interest rate or discount rate and the 2% escalation rate. You'll see what I mean as we go through the calculations. So we're going to start at the start here. There's a number of different ways of doing this, and just to kind of build your resilience in life cycle costing, I'll show you those different ways. Starting with the first, I suppose, stage here. This is a two-stage process. So I'm just going to delete what's in there. And what we're going to do is we're going to escalate that sum of money first. So in today's money, I've got €500. What it costs to basically, let's again use the example of floor finishes. So in today's money, I would replace those floor finishes for €500 in, let's say, a living room. How much would that be in 10 years at an escalation rate of 2%? So how much will it cost in 10 years if we assume that inflation is escalating at 2% every single year? So what we need to do is we're going to use this formula here for compounded interest, 1 plus E, inflation, or escalation to the power of n. So let's start with that, equals 1 plus E is the escalation rate. Put brackets around the end, and I'm just going to stick brackets at the start. And that is then shift 6 to the power of n being 10. Okay, and I'm going to put brackets around that at the end and at the start, and I'm going to multiply it by the sum of money today. Okay, so there's our calculation. Hit enter. So that €500 based on an escalation rate of 2% is $609.50 in 10 years. If I change 2% to, let's say, 5%, obviously it goes up because it's escalating at a greater rate. I'm not going to do that. I'll just change it back to 2. That's just to show you. Now what I'm going to do is similar to what I had in the last task or in the last sheet. I got that €500. I know what it is now. But in this case, it's actually 609. So I'm going to use that same formula to do the calculation on the single present value. So again, it's this 1 over 1 plus I to the power of n. So let's start with that. So equals 1 divided by 1 plus I being the discount rate, okay, to the power of shift 10 years. Okay, so let's put brackets around that calculation at the end and at the start to enclose it, and let's multiply it by the 609 because I'm discounting it back from that. Okay, so hit enter and I got 374. So it's a two-stage process. Stage 1 being inflating the €500, the 609.50. If I double click on the formula, I'll see what's happening there. And then the next one is double click, is discounting back that 609 back to a present value cost. So if I put €307 in the bank today, I'll be able to pay that floor finish. So what essentially is the present value of €500 today at a discount rate of 5% and an escalation rate of 2% is 374. Watch what happens if I change the discount rate and escalation rate to the same. So let me change that 5% to 2% and click enter. I'm right back to where I started. Now that is logical because on €500 in today's money, it escalates to 609.50, and if I discount it back at the same rate as I escalated, I'm back to 500. So the relationship between these two is everything in life cycle costing. If I put the escalation rate higher than the discount rate, it will change the dynamic. Escalation rate goes up significantly more, and I'm back at 2%. So I've actually got a present value cost because the relationship between these two is a little bit different than previously. I've got a present value cost that is actually higher than my money today, my cost of money today. So I'm just going to go back a few steps because I want to leave it as is, and that's 374. Okay, continuing on from that. That is kind of a two-stage process, and you might want to do that because you might want to represent those costs in both escalated cost and discounted cost. This is a process, or one-stage process that is below it, so I'm just going to go down a little bit. here we have a couple of calculations. I'm going to show you two ways of doing this one-stage process. It's essentially this single present value factor that encompasses both the escalation and the discount in the one calculation. So you'll see that from, or you'll remember that from our classes, our lectures, in terms of the explanation of the formula. If I'm to do it possibly using this formula manually, or I can use it using the power formula. Okay, so let's try this. Just going to delete what's there, and I'm going to use this formula here, this SP factor formula. So equals, and I'm going to start with a 1 plus E being escalation. Close the brackets, and then divided by 1 plus the interest rate. Brackets on that to start and finish. So that encompasses that first bit, and then I am going to put brackets around the end and the start. Hopefully you're getting the feel for these formulas and how they work with terms of brackets and the logical sequence of them. And then that calculation is to, let's hope it works, to the power of the 10 years. Okay, so that's our calculation there. Click enter. Oh, 0.75. Although what I need to do is, that's my factor, I need to put brackets around this end and around the start. And obviously I need to multiply the 0.75 by the 500 euro. Okay, so there's our calculation. I click enter. So there's my present value, 374.18, but it's within the one calculation where I'm both using my interest rate and my discount rate and my escalation rate. So it's escalating and discounting within the same calculation rather than doing it in a two-stage process. As I said, there's another way of doing that using the power functionality. So if I was trying to do that, I could click equals power, open brackets, 1 plus the escalation rate. Okay. Close brackets, divided by open brackets 1 plus the interest rate to the power of 10 years. Close the brackets at the end, put brackets at the start to close the calculation, and then multiply it by the 500. So that, I suppose, formula there, Excel formula, is pretty much the same as what's above, just done with the power functionality, and click enter and you can see it's the same. So again, if I changed 5% discount rate to a 5% escalation rate and have everything linked up, you can see that my present value is the same as my today's cost. If I manipulate my escalation, make it 1%, it starts changing. Okay, so my present value is a whole lot less than my today's cost of 500 euro. So I'm just going to go back. Just go back a couple of steps here. And there we have back to what was originally my 5% and 2%. So those first two calculations there. I'm going to move on to another way of doing it, where I calculate the real discount rate. Again, this is still calculating the single present value of this series of payments, taking into account a discount rate and an escalation rate, and the cost of that payment today, or what it would be today. Now, calculating the real discount rate of 5% and 2%. So let's say you think that that real discount rate is the discount rate minus the escalation rate, which essentially is 3%, but it doesn't work out that way. If you're to calculate the real present value or real discount rate of that relationship, you've got to use this formula here. So 1 plus I over 1 plus E minus 1. Okay, so let's try that there. There's the calculation. Let's calculate what the relationship between these two rates are. Equals, open brackets, 1 plus I being the discount rate, close brackets, divided by open brackets 1 plus E being the escalation rate, close brackets, then close again at the end, open again at the start. So that's that one calculation. or at least the first bit of the calculation, and then the next bit is minus 1. So let's click enter, and that is the factor. Let's change it to a percent, and it's 3%. Bring it back a couple of decimal places. Let's call it 2.94%. So it's not quite the complete difference, which is 2 minus 5, 3%. It's just below it based in this calculation. So let's pretty much, now that we have the present value rate, which is what we were kind of working on here, let's follow that same logic as what we were doing here in this calculation, but using the 2.94 rather than the 3%. Okay, so again, if we're to do the present value calculation on that, and that was using this calculation, we would click equals, as far as I remember, 1 minus brackets 1 plus I to the power of, if I remember, n being 10 years. Click enter. Oh, of course, same mistake as I did above. That needs to be enclosed because that's my factor. And then that factor, SPV factor, needs to be multiplied by 500 euro. Okay, so there we go. So we get the actual real present value, which is the relationship between the two, which is 2.94, and then just use our single present value calculation that we did in the previous sheet, and we click enter. And there we have it. I'll just bring that back. There we go, and it's the same as above. Just a different way, again, a third way of doing things, not to confuse the matters. I'm going to use the present value calculation here that I used in the previous sheet. So equals PV, open brackets, the rate is 2.94%. The number of payments is over 10 years. I don't have a payment every year, so I'm going to click 0. I do have a future value as such, and that is 500. Okay, and I'm going to comma 0, and then I'm going to multiply that, or I think I can actually return that payment, and there it is. Oh, it's giving me the minus 374, but that was because that G24 needs to be a minus figure, as far as I remember. Okay, there we go, and it's the same. Okay, so that's again using that present value calculation, similar to what I had done on this one here. Okay, and you can see the minus that should have been in there, and again, minus G24. Okay, so click enter. What I might do is, that's coming up as pound, I might just copy paste, click that there, so it's the same. So they're all the same, and they should be, they're just different ways of calculating. And then the last one here is using the power function, again with the real discount rate. So I'm just going to delete what's there, equals power, open brackets, 1 plus 2.94, close brackets, I believe, to the power of the 10, but I think it's going to be minus, and then close those brackets. I need to get rid of that bracket there. There we go. So 1 plus B, 27 to the power of 24, and then that's my calculation multiplied by the 500 euro. And click return. Just there's a few more decimal places there, bring them back in. And there we go. There's the 3 different ways of doing those calculations based on the real discount rate. So that's our tutorial for this week. Shows us both the single present value when there's no escalation rate as such, and the single present value on one-off payment when there is escalation rates. And again, I've showed you quite a few different ways of doing it. You won't be necessarily using all those when you're doing a total life cycle cost model, for example. But it's worthwhile knowing how those calculations are being put together. Thank you very much.